Welcome to this explainer. Okay, let's jump right in. Look at these two tiger photos. Imagine the picture on the left is a perfectly normal photograph of a tiger standing in the tall green grass. But look at the picture on the right. It's funny, stretched, and kind of squashed, right? The tiger looks super flat and very long. So why does one picture look totally normal to our eyes and the other looks so incredibly strange?
Well, today we're going to find out exactly why that happens. We are going to master Chapter 7 of your Grade 8 Mathematics textbook, which is called Proportional Reasoning. We will uncover the simple mathematical rules that make things look either perfectly balanced or completely distorted. Here is our roadmap for today. We will cover spotting similar images, ratios and simplest forms, solving proportional problems, the rule of three, and finally, sharing things unequally. Let's get started.
First up, Section 1, Spotting Similar Images and Comparing Shapes. To find a pattern here, let's measure our images using millimeters. Picture a table of numbers in front of you. On the top row, we have Image A. It is 60 millimeters wide and 40 millimeters high. That is our normal, beautiful picture. Now jump down to the bottom row, Image C. Notice how the numbers are exactly half. It is 30 millimeters wide and 20 millimeters high. Because both the width and the height were cut exactly in half, Image C will look just like Image A, only smaller. But check out the middle row, Image B. The width is 40 and the height is 20. Something is very different there.
And this brings us to a really important rule. Let's look at Image B again. The width went from 60 down to 40. That means we subtracted 20 millimeters. The height went from 40 down to 20. That is also a subtraction of 20. That here is the catch. Subtracting the same amount distorts the image. It makes it look completely squashed. To keep the shape looking perfectly similar, we absolutely must use multiplication or division. Dividing both the width and the height by 2 or multiplying them by the exact same number is what keeps the image looking perfectly natural.
Moving right along to Section 2, Ratios and Simplest Forms, where we understand proportions. So we actually have a special name for this relationship. We call it a ratio. A ratio is just a simple mathematical way of comparing two quantities. When we write it down, we put two little dots in the middle, kind of like a colon. We read it out loud by saying A is to B. For example, the ratio of the width to the height of our first normal tiger image is 60 to 40. We call the numbers 60 and 40 the terms of the ratio. This simply means that for every 60 units of width, we have exactly 40 units of height. Now, what's really cool is how we can make these big, clunky numbers much easier to work with. We do this by reducing ratios down to their simplest form. Step 1, we find the highest common factor, or HCF. You might remember this from earlier classes. For the numbers 60 and 40, the biggest number that divides both of them evenly is 20. Step 2, we just divide both terms by that 20. 60 divided by 20 is 3. And 40 divided by 20 is 2. So our simple, super easy to read ratio is just 3 to 2. Now, when two completely different ratios simplify down to the exact same numbers, we say they are in proportion. We show this relationship using a very special symbol, 4 little dots placed right in the middle. We write A is to B, then those 4 dots, C is to D. This is just a fancy mathematical way of saying that the first ratio is perfectly equal to the second ratio.
All right, on to Section 3, Solving Proportional Problems.
So what if you have an unknown number in a proportion? Say you know 3 of the numbers, but you're missing the 4th one. Well, you can use a wonderful trick called cross multiplication. Imagine the 4 terms lined up straight in front of you, A, B, C, and D. If you multiply the outside terms together, that is A and D, the answer will perfectly equal what you get when you multiply the inside terms together, which are B and C. Simply put, A times D equals B times C. It is a real game changer for solving these problems quickly. Next up is Section 4, the rule of 3, looking at some amazing ancient Indian math. We can take a lot of pride in knowing that in ancient India, the brilliant mathematician Aryabhata was solving these exact types of problems way back around the year 1990 CE. He called his method Trirazika, which translates to the rule of 3. He used 3 known numbers. He called them the measure, the fruit, and the requisition to easily find that 4th missing number. Let's see how this ancient wisdom can actually help us today. Let's try Aryabhata's method on a school midday meal problem. Imagine a school cook. Normally, if there are 120 students, the cook knows they need exactly 15 kilograms of rice. But today, maybe because it's raining heavily outside, only 80 students showed up. So how much rice does the cook need now? We can write this as a proportion. 120 students is to 15 kilograms, as 80 students is to, well, our unknown number.
To find the answer, we just look at how the number of students changed. We put 80 over 120. First, let's cancel out those zeros. That gives us 8 over 12. Then we can divide both the top and bottom by 4, giving us a nice simple fraction, 2/3. This means we only have 2/3 of the students today. So we take our usual 15 kilograms of rice and multiply it by that fraction, 2/3. 15 multiplied by 2 is 30, and 30 divided by 3 is exactly 10. This simple math tells the cook to prepare exactly 10 kilograms of rice today. No extra food gets wasted.
And finally, Section 5, sharing things unequally. Now, usually when we share things, we like to share them equally, right? Imagine sharing 12 items between two friends. Sharing equally means a 1-to-1 ratio. You get 6 items and your friend gets 6 items. Fair and square. But what if one friend did a lot more work? Sharing in a 3-to-1 ratio means the items are not split right down the middle. In a 3-to-1 ratio, out of 12 total items, one person gets 9 and the other person gets only 3. Let's look at exactly how we calculate this.
To solve these unequal sharing problems quickly, we use a really simple rule. We take the ratio, let's call the numbers m and n. First, we just add the two parts of the ratio together, so m plus n. This gives us the total number of parts. Then we take the specific part we want, let's say m, we divide it by those total parts, and we multiply that fraction by our total amount of items or money.
Let's apply this to a real-world business problem. Imagine 2 students, Prashanti and Bhuvan. They started a little food cart near their school, but they invested very different amounts of money to get it going. Prashanti put in a very large amount, 75,000 rupees. Bhuvan put in a smaller amount, 25,000 rupees. Now, at the end of the month, they earned a total profit of 4,000 rupees. They want to share this profit fairly, based strictly on exactly how much money they each put in.
First, we write down their big investment numbers as a ratio. That's 75,000 to 25,000. Step 2, we reduce this down to its simplest form. We can just cancel out the 3 zeros from both sides. That leaves us with 75 to 25. And since 75 divided by 25 is exactly 3, their simplified ratio is 3-to-1. Now for step 3, we add these parts together. 3 plus 1 gives us 4 total parts for the entire business.
Okay, now we take that total profit of 4,000 rupees and divide it by those 4 total parts. 4,000 divided by 4 means that every single part is worth exactly 1,000 rupees. So visualizing this profit split, Prashanti gets 3 parts. That is 3 times 1,000, giving her 3,000 rupees. Bhuvan gets 1 part, which is 1 times 1,000, giving him 1,000 rupees. And this just perfectly shows how ratios can help us solve real everyday business problems completely fairly. Before we wrap up this explainer, I want you to try something fun. Look around the room you are sitting in right now. Find a rectangular window, or maybe a door. What do you think its width to height ratio is? Do you think the shape of that door is proportional to the shape of the math textbook sitting on your desk? Think about it. Maybe grab a ruler and measure it yourself. Thank you so much for learning with me today, and always keep looking for the beautiful math hiding all around you.